Hi everyone, this is part 1 of lecture video for topic 2.1, rates of reactions. In this video, we will be focusing on first two boxes that appear on this table. Sorry, this table. So the rates of reaction at different times can be compared by considering the slope of a graph, quantity or concentration of the reactant or product against time. You need to be able to draw and interpret graphs representing changes in quantities or concentration of reactant or product against time. And also, rates of reaction can be influenced by a number of factors, including the presence of inorganic and biological catalysts, which is enzymes. You need to be able to predict and explain, keyword there, predict and explain, using collision theory, the effect on rates of reaction due to changes in concentration, temperature, pressure for reactions involving gases, surface area, and the presence of a catalyst. We'll talk about energy profile stuff after this video, next video. All right, let's move on to this one. So if you look at the page 1 or 2, figure 2.11 on essentials workbook, you can find the two graphs actually, the rate of formation of product as well as consumption of a reactant. You would notice that if it was a consumption of product, it would look a bit like that. Start off with really high number or very steep slope to something that has much lower slope. And you can measure that in unit of moles per liter per second or grams per second. It's a concentration over time, concentration change over time, time unit, or mass or amount that increase, decrease over time. Could be second, could be minute per minute. If you know how to work with mole ratio, and if you knew the chemical equation and how much is consumed, and how much should be coming out, like say 2-to-1 ratio. For example, if you are breaking down H2O2, hydrogen peroxide, from 2 molecules of hydrogen peroxide, you should always get 1 mole of oxygen. And if that's escaping, you should see the mass of a beaker full of hydrogen peroxide decreasing. And knowing how much oxygen gas has escaped, using the mole ratio, you should be able to see how much water was also generated or produced by the reaction. So that calculation can be done if you know how to work with the ratio. Measuring rate of reaction, there are 2 ways of doing it, instantaneous and also average. Now, if it's an average, average and instantaneous reaction can be figured out by using the equation that you see below. Rate of reaction equals to either change in quantity of product or reactant over time. Change in quantity, so masses, or change in concentration of product or reactant over time. Now, average rate, I'll zoom into that one there. Yep, with the focus. All right, so if you are looking at consumption, right? Yeah, consumption of a reactant, because we are starting from somewhere high and there's much lower amount or concentration of a reactant here. You could figure out concentration of this in a few different ways. So firstly, let's look at average. So if you're looking at say time at 5 sec, and maybe that being 10 seconds, and this being, I don't know, 30 seconds. So 5, 10, and 30. You could be looking at average rate of change from A to C. How do you do it? You just draw a straight line. Straight enough. And once you could figure that out, you could then look at rise over run, this being rise, but negative because it's, it went down this way. Rise was a concentration and run is time. So concentration over time. You can also see that in unit, moles per liter over second. Moles per liter per second. That's what you would do. And that's really just run over rise. Now, that's for the, what did I say? Average rate of reaction. You can do the similar thing for instantaneous. Sorry about the focus. Instantaneous rate of reaction. You can do that for the A and C separately. What you do, if you are using graph, you just draw a perpendicular line to the point, and then again drawing a perpendicular line. That's really a tangent, yeah. You can also draw a tangent line, well, at any point. Okay. If you could do the similar thing, that being 90 degrees, that being 90 degrees, you can do rise over run calculation there, rise over run calculation there, and you will for sure find that the slope value is much lower for C and so much higher for A. So that's what you would see on the next slide, and that's something that you could copy onto the graph. Okay, try even doing those calculations that I just showed in the space there. All right, let's talk about factors that affect the reaction rate. Now, you guys did rate of reaction stuff since year 10. You may have even done collision theory stuff in year 8. I remember teaching that the year 8 science class. From experiments, you should already know most of these, but you also need to be able to now use collision theory in your explanation, and also to predict what's going to happen if you change these factors below, such as nature of the reactant. If you are dealing with acids and bases, well, I hope you know that acid and base, they just react with each other really quickly. So you can't really tell how fast the reaction is in, say, concentration over time. It's going to be very high number. Whereas if you are, say, dissolving zinc into sulfuric acid, 2 molar one, it takes still a few hours for the zinc to disappear. So yeah, you can work out a rate of reaction from that, and it's going to be much lower slope value compared to acid and base. Concentration of the reactants obviously increases the frequency of the collision. Temperature of the reactants, well, frequency might even change because particles are moving faster, and also they would have enough energy to go over the hump of activation energy. We'll talk about that in the next video, but that's what you need to be able to kind of explain and predict. The pressure of the reaction, if you're working with gaseous system, how does it work? If you pressurize a vessel, how would it look like, feel like, as molecules or particles floating around in that vessel? You can also talk about surface area. So the state of subdivision of the reactants, particle size. If you had a big clump of it, the ones in the middle, they won't be able to react as well as the ones on the outside surface of the clump. Reactions which are affected by light, they are called photochemical reactions. So if there was no sunlight for, say, photosynthesis, what's going to happen? Or if the sunlight was not as intense, like, say, winter compared to summer, how would the reaction rate be affected? Finally, presence of catalyst. For some reactions, yes, catalysts are available and can be used. If it's an inorganic ones, right or not, nickel is your, or actually platinum as well. They are very common ones to be used in the industry. Or you would have even heard that in catalytic converter in environmental chemistry stuff. And you also have enzyme that's available in a biological catalyst. How they work, well, you need to learn about that next video, or actually in this video too, next two tables. These tables are important for you to be able to talk about how those factors change the reaction rate and explain. Now, so naturally you should be focusing on the examples and also explanation. Explanation column is very important. For example, temperature. What did we say about temperature? How does it affect the kinetic theory or particle theory? Look at the explanations there. Particles have more kinetic energy, hence a collision is more likely to produce an activated species, the products that is, or species that can go over the hump of that energy diagram. Again, you will see it later again. Let's also look at the catalyst one and the explanation of it. It says catalysts can provide an alternative pathway. Now, alternative pathway is a keyword you should highlight or underline. Okay? For a reaction, it may provide a surface for the reaction or orientate molecules correctly. Basically, it changes the activation energy, reduces activation energy. So that's what it does. That's what catalysts do. And that's an explanation that you need to be able to use to describe, what's the word again? Predict, yes, predict or explain how the reaction rate would change. All right, I believe this is the end of, first video. So, if you didn't understand anything, make sure that you write notes of it and ask me again. All right, see you in the next video.